Complexity stems from information density. Between these two strings, which one truly requires more data to describe? This repeating pattern indicates low complexity. Because the string is highly predictable, we can describe it using a very simple rule. Conversely, random strings lack internal structure. Without a visible pattern to exploit, we cannot find a simpler shortcut. A pattern is essentially a shortcut for information. By recognizing repetition, we can transform a long string into a rule, significantly reducing the bits required. However, randomness is essentially the absence of patterns to exploit. When a string lacks structure, no algorithm can find a shortcut, making the shortest description the raw data itself. Kolmogorov complexity defines information as the length of a string's shortest description. Within this logic, K of X is just the minimum-sized program capable of outputting our data. Complexity equals recipe length. To measure description length precisely, we use computer programs. Any code that outputs a string is a valid recipe for that data. Structured strings have low complexity because a tiny recipe can recreate them, drastically reducing their total information content. In contrast, random strings lack internal structure, so they cannot be summarized. When the recipe is as long as the data, the sequence is truly complex. Complexity is machine-independent because computers can translate each other. This constant C is simply the translator size, keeping K consistent everywhere. Is this string of pi digits complex? Paradoxically, no, because a short program computes them all. The Kolmogorov complexity is low. Predictability comes from simple recipes. We can view complexity as a spectrum. Simple patterns sit on the left, while pi occupies the middle. True randomness lies at the right. Statistically, most data is devoid of structure. While some allow compression, the majority are incompressible, meaning the shortest description is the data itself. Imagine a perfect machine, capable of calculating Kolmogorov complexity. This ultimate randomness detector would instantly separate signal from noise. Yet, Kolmogorov complexity is incomputable. Defining the shortest complex string creates a paradox that no program can solve. Berry's paradox shows the danger of vague descriptions. Kolmogorov complexity resolves this contradiction by using precise code to define exactly how we describe a number. True complexity is simply the shortest recipe size. Structured strings have tiny descriptions, while randomness requires much more.